All right, now we're going to do the second free response from review day 13. We've got two particles in motion given to us. The first one, we're given its position function, but for the second one, instead, we're given just its velocity. So you got to be real careful about what each of these equations represent. So part A says from 0 to 8, when is particle P moving to the left? So this is the position function. We have to find the derivative of that to get its velocity. So derivative of natural log is 1 over what's inside the natural log times the derivative of what's inside the natural log, 2t minus 2. If you want, you can write that up on top. Now, I'm sure some of us spent quite a bit of time trying to factor this out, trying to see what happens here. The AP was being a little bit mean on this one. The truth is this is always greater than 0. It doesn't have any roots or anything, so you could do it all day if you want. It'll never break down, which makes it a little bit easier because then we really are only interested in the top. Since this is always positive, only what would make the top negative is what's going to make this move to the left and give it a negative velocity. So this is 2 times t minus 1. So that equals 0 when t equals 1. And if we're less than 1, so if you do your little check here, anything less than 1 would give you a negative. Anything greater than 1 would give you a positive. So therefore, we would say that we're moving to the left from 0 to 1. So remember, this only was true from 0 to 8. So from 0 to 1, we're moving to the left. From 1 to 8, we're moving to the right. We're going to keep this in mind for later on in this problem. All right, we'll just kind of box that up for us here, because we'll come back to that. This is particle Q. No, get it right, particle P. All right, what do we have to say? We said that it's the interval 0 to 1 because that's where x prime p of t is less than 0 is negative. You got 1 point for the correct derivative. You got 1 point for the interval with the right explanation. Okay. Part B, find all the times where the two particles travel in the same direction. So now we know what direction P is going from 0 to 8. Now we got to figure out what's going on with Q. So we'll do that down here for part B. I'm going to take the velocity equation for Q. I'm going to factor it into t minus 5, t minus 3. All right. And so therefore t equal 3 and 5 are my places where I'm at rest. If I check before that, anything, if I say put 0 into this, I'm going to get a positive. If I put, say, 4 in, I'm going to get a negative. If I put in, say, 7, I get a positive. So I'm moving to the right between 0 and 3, left between 3 and 5, right between 5 and 8. Now, if I bring back, so here's 0 again, and here's 8. So if I bring back the other one, at 1, we said we were moving negative, and every other time we were positive. So kind of look at the intersection there, and you can kind of see that between 1 and 3, both of these are positive. So we would say between 1 and 3, okay? And then between 3 and 5, this is negative, this is positive. And then between 5 and 8, they're both positive. So between 5 and 8. All right, that's where both of them are moving in the same direction, and so you got a point for those intervals, and by showing your work here with your velocity, you got a point on that too. All right, part C says find the acceleration of particle Q at time 2, and are we speeding up or slowing down? So we've done tons and tons of this. What we need to do is compare the velocity with the acceleration, right? So our velocity at 2 would be 4 minus 16, negative 12 plus 15 is a positive 3. So we have a positive velocity. Okay, then we're going to take the acceleration. So the derivative of this is 2t minus 8. So the acceleration at 2 is equal to 4 minus 8. That's a negative 4. That's less than 0. So we would say the speed is decreasing because velocity and acceleration have opposite signs. All right, so they gave you a point for finding the acceleration there, and then they gave you a point for having the correct explanation as to why it's slowing down. All right, then the last one says find the position of Q the first time it changed direction. So the first time it changed direction was at t equal 3. So we're trying to find the position at t equal 3. So we'll do that down here. Anytime we try to find a future position, we have to ask ourselves, where was it before? According to the problem, particle Q had a position of 5 at t equals 0. So we're going to have 5 here, plus the integral from that time to the time we want, which is 3, of its velocity, which was given to us as t squared minus 8t plus 15. Okay, so now we're going to go 5 plus t cubed over 3 minus 8t squared over 2, so that's 4t squared, plus 15t, doing that from 0 to 3. All right, and then we're going to put that in. So we'll have 3 cubed divided by 3, that'll be 9, minus 4 times 9, 36, plus 15 times 3, 45. And if we work that all out, we should get 23 for our answer. Now, that's the 3, obviously minus 0, 0, 0, so we do the fundamental theorem on that, but we end up with 23. So they gave you a point for remembering to use 5. They gave you a point for setting this up and getting to here, and then a point for having that final answer there. All right.